calorimetry. Okay, you probably talked about calorimetry back when you were in chemistry class, but if not, or if you do not recall, calorimetry is used to find the specific heat capacity of an object. Okay, and what that is that's the amount of energy, okay, in the form of heat that is transferred from one substance to another. Okay, let's talk a little bit more about specific heat capacity. Specific heat capacity is an object's resistance to change its temperature. Okay, so how much or how easily it is to change an object's temperature. Okay, the symbol is C sub P. Okay, and that's because we are talking about the specific heat capacity at a constant pressure. Okay, you could have a specific heat capacity for a constant volume that would be different, okay? But in our class, we are going to use C sub P because we're going to be doing this for when the objects are at a constant pressure. They're going to be open to the atmosphere, okay? So they'll be at atmospheric pressure. Units for specific heat capacity are joules per kilogram times degrees Celsius. And the equation is Q. Remember, Q is the heat, the symbol for heat. So the amount of heat that's needed is equal to the mass times the specific heat capacity times the change in temperature. And whenever we find the change in something, we take the final minus the initial. All right, so let's talk a little bit more about specific heat capacity. Well, let's go ahead. Let's look at aluminum. Okay, aluminum has a specific heat capacity of 899 joules per kilogram degree Celsius. Okay, and compare that to water. Water has a specific heat capacity of 4,186 joules per kilogram degrees Celsius. So what this means is that if I want to change the temperature of aluminum, okay, and I have 1 kilogram of aluminum, and I want to change the temperature by 1 degree Celsius, I need to add 899 joules. Similarly, if I want to raise 1 kilogram of water's temperature by 1 degree, I need 4,186 joules of energy. I need like 4.5 times more joules of energy to change the temperature of water than I do to change the temperature of aluminum. Okay? So water has a larger resistance to changing its temperature. Think of this when you're at the beach, okay? We know water has a fairly high specific heat capacity, okay? On the other hand, sand, I don't know what its specific heat capacity is, but it's significantly lower than water, okay? Think about this. You go to the beach in the spring, okay? The water has been cold from being in the winter time, all right? And it's going to stay cold because it's going to take a lot of heat, a lot of energy to raise the temperature of the ocean because there's a lot of stuff in the ocean, okay? It's big, okay? Lots of mass there, all right? Now, sand, on the other hand, okay, has a very low specific heat capacity. So its temperature changes more easily. So the sun can come out and it's going to raise the temperature of the sand fairly easily. The water, on the other hand, it's going to take a lot more heat, a lot more energy. So the sand might feel warm while the water still feels cold. Then you go back there in the fall, and now the water's finally heated up from all summer, okay? It again is going to have a large resistance to change, so it's going to stay warm for quite a while. So on a cold fall day, the water is going to feel a little bit warmer than the sand, okay? Specific heat capacity is an object's resistance to change its temperature, okay? And calorimetry is used to find the specific heat capacity of an object.